Here we're asked to take the intersection of two sets. Now they're both complicated inequalities, these sets. The first set are the solutions to the inequality 2x minus 5 is greater than negative 1. And the second set are the solutions to the inequality 4x plus 2 is less than or equal to 16. So in order to do this, we have two steps. Step one is to simplify each of these two inequalities. In other words, to get the variable alone on the left side. And then to stack the number lines and put a third number line below to take the intersection. And we have to keep in mind the upside down cup represents the intersection, as does the word and. The thing to remember about intersections is that in order for an element to live in the intersection, it must live simultaneously in the first set and the second set. So let's go ahead and do step one, where we're going to simplify the first inequality, 2x minus 5 is greater than negative 1. Let's move the 5 over by adding it to both sides. Then we have 2x is greater than 4. Let's eliminate the coefficient 2 by dividing both sides by 2. We get x is greater than 4 over 2, which is 2. And, bring down the and, 4x plus 2 is less than or equal to 16. Move the 2 over. 4x is less than or equal to 14. Eliminate the 4 by dividing both sides by 4. And simplify x is less than or equal to 7 halves. And just to be able to graph it, just remember 7 halves is equal to 3 1/2. Okay, let's now do the graph. This is step 2. X is greater than 2. X is less than or equal to 7 halves. So let's see, the smaller number would be 2 because 7 halves is 3 1/2. And then we'll have the intersection graphed on the third line below. Okay, so we stack up the 2's. We stack up to the right of that the 7 halves, which is the same as 3 1/2. And now we shade for the first set everything that's greater than 2. And do not include the 2, put a round bracket. For the second set, we're going to shade everything less than 7 halves and include the 7 halves because there's an equal portion, put a boxy bracket. Now, intersection, think about it again. To be in the intersection, you must live simultaneously in both of the above sets. So first look at the values of x that are less than 2, to the left of 2. We have no values of x less than 2 in the first set because there's nothing shaded there. But on the left side of 2 in the second set, we do have shading. For the intersection, we're only going to shade the regions that have shading in both of the inequalities above, and that will not be the case for values of x smaller than 2. So do not shade the region to the left of 2 for the intersection. Now, continuing on, let's see. Between 2 and 7 halves, yes, they both include values between 2 and 7 halves, so shade that. And nothing to the right of 7 halves because that only occurs in the first set but not the second set. And we are doing an intersection here. The reason we have a round bracket on the 2 is because 2 is included in the second set. It's shaded right through the 2, but it is not included in the first set. There's a round bracket on 2. It is not included, so it cannot be in the intersection. The reason we have a boxy bracket on 7 halves is because in the first set, 7 halves is shaded right through, so it's included. And in the second set, we have a boxy bracket on 7 halves, which indicates it also is included. Therefore, 7 halves is included in both of the sets, and that puts it into the intersection with a boxy bracket. Now write that graph in set notation and in interval notation. All real values x such that 2 is less than x is less than or equal to 7 halves, or everything from 2 to 7 halves, round bracket on the 2 because we're not including it, boxy bracket on the 7 halves.